I'm good. So what are we gonna learn today?
I want to show you today how we teach topics in science with the MyQ Cosmos. So we have multiple subtopics already, but I'll demonstrate the flow of work with the electric conductivity. Ready?
Yes, can't wait.
Let's see how it works. Simply by going through a lesson, we'll run one or two missions, get the concept, and then you can continue on your own. Okay, so what's unique with Cosmos is that we let the children learn the topic by watching a simulation, but not only watching and playing with the simulation, but actually influencing it, building it, adding more and more behavior with a special language of rules that we'll see in a minute. So the
Ah,
work
okay. So that's the difference between Cosmos and FET that they can.
Definitely. With fact,
Okay.
you have beautiful simulations, but what you can do there is playing with parameters. You can increase certain things, decrease, add, see how it behaves. You get a beautiful visualization that helps you grasp a concept, but you don't really understand necessarily how things work, what made one thing happen and another thing remain the same. So here you'll see in a minute, we have additional layer over simply watching a simulation and playing with it, which is the layer of adding behavior, defining yourself what the simulation should or should not do. Okay?
Yeah.
So a lesson with the Cosmos is built of missions. Here you can see we have 13 missions in this lesson. We'll do only one or two in this short demonstration. But the students, as they move from one mission to another, they learn more and more things of the same topic until the end of the lesson where they get the full picture of how things work. So let's start with the electric circuit, and we start by learning about the switch. As soon as we click got it, move on from the mission details to the actual mission task, the screen is split into two. On the right, we see, maybe it's your left, we see the simulation. And it's a really naive, almost do nothing at the first phase. Like here, for example, I can only turn on and off the switch, and you can see that the circuit is open and closed, but nothing else happens. See, the ammeter doesn't move, the bulb doesn't do anything. And on the left, we see a set of rules. You can see that the rules are missing and we need to complete them. For example, those cards that have red frame, like here, there are missing cards which we as students need to complete in order, and the rules, once they are complete, they influence the way the simulation works. So let's see an example. Here the student receives an explanation that the circuit switch is a component that enables the closing of an electric circuit and the operation of electrical appliances, such as the light bulb. Complete the rules below in a way that will describe the relationship between the switch and the electric circuit and between the electrical circuit and the light bulb. So let's read the rules. The first rule says, when the switch closes, then the circuit, and when I click the missing card, I'll see the options that I have to fill in the missing card. So what do you think? Help me here. When the switch closes, then the circuit closes or opens?
Closes.
Let's give it a try. The next rule says, when a circuit closes, then the bulb
Will light up. Turns on.
turns on. Okay. So let's see now what happens if I run the simulation. Remember, I can only click the switch at this point, and before, when I clicked it, nothing happened.
Yeah.
Now that I click it, you see the bulb turned on. This is simply because we told the simulation what to do. So once we did this, and by the way, the students, if they're not sure how to continue, they always can use the hints that are here above every rule. There are 2 hints. The first one is more vague, just give them a tip that maybe will change their way of thinking. But the second one, need more help, will almost always give them the solution, so they're not stuck and they can continue.
Okay. Oh, that's
Yes. And I want to show you one more thing, that with our simulation, one of the things we think is very valuable and we are also very proud of is that you can make mistake and see what happens when you make mistake. So here, for example, if I said that when a switch closes, then the circuit closes, but when the circuit closes, the light turn off, for example, this is not a likely mistake, but there are missions that are more complex and there it's more significant. But then when I run the simulation, the light will not turn on, even though the circuit was closed.
okay. So how do they know they made a mistake?
All right, so let's leave in the mistake here and let's move on to validation. In every mission, once they complete the mission task, completing the rules and see how they behave in the simulation, the student moves to validation to check that their solution is correct. And here you can view it as a lab. We run the test, we run the experiments of what we did. So it says here that in this experiment, we will check what happens to the circuit and the light bulb when the circuit switch closes. Let's start the experiment. I get an instruction to click the switch to close it and hit the done. The system will check that the electrical circuit is closed and that the bulb turned on. The system will check the right behavior. But if I didn't model the simulation correctly, I will get an error, as we can see here, because it expected the light bulb to turn on. It wasn't, so I get an error. And I can go back to modeling, fix my model. I can use the hints if I didn't so far.
Then validate it again. Got it.
Then validate it again. And once the validation succeeds, I move on to the next mission. So let's just see it in action. Click the switch. Indeed, the bulb turned on. The system will check it. I get a green B sign and a congratulation notice. For example, in this mission, we talk about the conductivity of the materials. So you can see that I get here three new buttons that imply the material from which the circuit is made of. So right now it's a copper, and then I can switch it into wood and into plastic. And the students learn that the conductivity depends on the material, that each material has a different conductivity. And then we move on to missions in which, to missions where we add more electric devices to the simulation. Let me skip. Here, for example, we add more electric device to the circuit, and we see how they influence the current of the circuit. I skipped the missions where we show the student that.
Yeah, so the missions are built, right? You have the first mission and then the second and the third.
Yeah, and they build one on top of the other.
Yeah.
And
okay.
Yes, and so they learn how electric device influence the circuit and how they are influenced by the circuit and by the energy source. And later on, we add the resistance of both the resistant element and the wire itself, and so on and so forth. And let me skip to the last mission. I'll skip like that, even though the students will not be able to skip. They will have to solve each mission in order to move on to the next one. But the teachers themselves can skip it. And I'll move up to the last mission to show you a few things. First of all, when we get to the last mission, we are already introduced the electric device, the switch of them, the resistance of the resistance resistance, the energy source, the fact that the resistance is influenced by the length of the wire and the depth and the width of the wire, and so on and so forth. And the one important thing I want to show you as a teacher is that you can always, in every mission, see the solution of a mission. So here, even though we skipped many, many missions and we didn't solve them in this demonstration, and you can see that there are many rules, missing rules here, I can move to a solution workspace. You see where I'm at?
Yeah.
I can move to the solution and get the full solution of this mission. And seeing the full solution, I can also run the simulation. So let's see what happens when I close the switch. Here is the current flowing through the circuit. That's something that the students learned in one of the missions, that the current is there. And you see, I don't know if it can see, if you see it
Yeah, it's moving.
clearly through the Zoom, but you can see that the speed of the current is changing. Now it's slower because there is more resistance. Now it will be even slower because the width is shorter. And if I'll add more electric devices and we'll turn them on, the current will be even slower. The intensity of the current decreases as more and more devices are added to the circuit. And again, that's something the student learned along the lesson. Also the energy source and so on. So that's how they can work through the missions and see the simulation in action based on the rules and the way they filled it in. They run through the validation, they validate their model, everything is visualized, it's very clear to them what happens and why they have a full explanation here in the rules that they had big part in defining them. So it's, you know, we believe and we see it also by running questionnaires that the material is really, they digest it better, they understand better what happens there, more than just listening to an explanation or even playing without understanding why things happen. And we find it very valuable that they make mistakes, because when they make mistakes, they have to understand better what the mistake was and how to fix it. So it's a valuable process. So we don't ask them to make mistakes, but we think it's very valuable. So that's how we teach with Plethora. I want to show you one more thing for the teachers, how they can track what happens in the class. So the teacher have a dashboard here on the top left.
Mm-hmm.
When I click the dashboard, I move to a different view, a view of the class, where we see all the missions. Here I'm on a different, I'm on a demo account here, so I'm showing you a different lesson, which is the only one active here. But you can see that all the missions are displayed here and the students of this class. And for each student, I can see exactly what happened in each mission. For example, the first student here only skipped through the mission. He did not run any of the experiments. I can see all the white stars. It means that it didn't do anything. The
Oh,
second,
he just jumped from mission to
yeah,
mission?
yeah,
Okay.
maybe played with the simulation. Maybe he filled in the rules. I can see whether or not he did it. I can click a mission, and then the eye appears here. And if I
Oh,
click,
yeah.
if I click this eye, I move to the student's workspace. So I can see whether or not they fill in the rules. And here, this student didn't fill in the rules.
Oh, wow. That's very helpful.
Yes. I can also see the red stars means that they did run the experiments but failed the experiments.
Mm-hmm.
And the green stars indicates that they run the experiments and succeed. So
Okay.
with one view, I can see really the details in depth. By the way, you see here there's the yellow bulb. It means that
Yeah.
this student in mission 4 used a hint.
Oh, okay.
The rest didn't use hints. And if he would use 2 hints, the bulb will be displayed in red. So I also
Oh,
get indication whether they use hint or not. I'm not saying it's a good or bad thing. It's for your judgment, because using hints is not necessarily a bad thing, but we can see it here. And one last thing before we finish is the progress screen. The progress screen is a sort of a class view. It
mm-hmm.
shows me how the class progressed together. You can see here the number of missions for all the class, meaning, sorry, not the missions, but the number of experiments. So
Okay.
take the number of experiments per lesson, multiply it by the number of students in the class, and that's the number you see here. And this is the number of experiments already done. So with this view, we can
Oh,
show it
you can
on,
have competitions between classes
let's
and
call it a joint mission of the class.
okay.
You can define a competition between classes, but
Yeah.
at the minimum, you can display it on the screen and give the class a joint mission to progress together in the lesson. The more experiments they will run successfully, this purple bar will progress, and they will see how they progress in the lesson, and eventually finish the lesson together. So
Oh,
that's
wow.
another thing we provide to the teacher as a tool.
Okay, it looks very exciting. Thank you so much, Smada. I can't wait to try it with my students.
You're welcome. Give it a try and let us know if the student liked it, and if you liked it, and how was the lesson.
Absolutely. Thank you. Have a great
Thank
day.
you. You too. Bye bye.